can we bring the cutting edge of contemporary science into the modern classroom?
You've each got a type of sorting algorithm. What I want you to do is actually do a stop motion video, okay, of how that sorting algorithm would sort some numbers.
I'm Peter Corkill, I'm the principal at John Monash Science School. I'm also the founding principal. The school began here in 2010. It's Victoria's first specialist school in science, mathematics and associated technologies.
So why does changing the enzyme, why do you think that changes the interaction with the antibiotic? Do you know what it actually does?
I'm pretty sure that it's because the enzyme in the antibiotic breaks down the bacteria, the properties in the bacteria, so then altering it prevents it from doing that.
So it's basically changing the shape of your antibiotic?
Yeah.
So the first thing is to make it genuinely engaging and interesting, giving them some access, but challenge at the point of need and support when it's appropriate. So that, you know, it's very important to us that teachers know the students, know them as people, but know them most importantly as learners.
If we say that the cart must travel a minimum of 80 centimetres.
We just do simultaneous. Like you make them both 80.
Would you make them both 80?
Oh, no,
what's going to happen if you made them both 80?
You have to make the time the same, wouldn't you?
Yeah, you're going to have to find the time.
Yeah, the time.
If you did make them both 80, which one's going to hit the ramp first?
The one with great acceleration.
Yeah, the steeper one. So you know that without you've played Hot Wheels track down the hallway at home, you know that's going to happen.
And the other thing we're very hot on here is to explain to everyone in a class of 52, 2 teachers and 50 students, that apart from you, there's 51 other people here that you can learn from. And all of the ideas and the resources, it's not just the teachers. You know, your classmates know a lot of things as well. And if their understanding is clicked in before yours, well, make use of it.
So our body actually has checks in place to make sure that the cells that are produced are the correct ones. Very good, great question.
What's the difference? Did you ask what's the difference between germ cell and game? Somatic cell.
Why don't you explain? And I'll listen.
So for germline cells, we create 4 different daughter cells.
I have a personal philosophy that science should be very hands-on. You can design activities, particularly in mathematics, which will allow students to discover some of those big laws for themselves, and I think they get a real buzz out of that. And I'm also fairly convinced over what I've seen for a long time now is that those ideas will stick longer because they've actually made the links themselves, they've actually come to that belief.
So what else could you check? If you think this one's taking longer, what else could you check?
Friction.
Yeah, we're saying the friction, when we did it, the friction was practically negligible. Are you sure of the angle? If the angle's going to contribute to the acceleration, I'd remeasure the angle.
We generate feedback data on every student once a month, and we number crunch in houses and in subject areas, so we know the kids that are ahead, and we need to keep pushing them further. We need to create more opportunities for them. All of the teachers fill out a written report on whether the students are ahead of the game, with the game, a few minor concerns, or maybe a major concern. You know, the kids that are ahead of the game, you know, big question, are we doing enough for them? Are we challenging them at the point of need? And that's why it's a really great idea to teach in teams, because many of our teams have expertise in science that maybe the other teacher doesn't.
Are we going to get them to work on one side or the other, or are they going to do a combined board that includes both ideas? Seems that we've hosted discussions on both sides. What do you think? I know that's not exactly what's written in the lesson plan.
No.
There's an idea.
I think that's fine. I think that'll be good.
Yeah?
Yeah. So let's maybe divide the board in half then.
Yeah.
And go half of it with how can you acquire antibiotic resistance, half of it how does it then work.
And we're still learning. We're still learning from each other and from the students, and you know, we're about to enter into the second major strategic planning period of the school, and team teaching will still be a major platform for continued development so that we get the very best out of it.